Welcome in the subject engineering materials and metallurgy. Today we will see the important chapter of our subject, ferrous materials. So there are basic two types of materials, that is the ferrous materials and non-ferrous materials. So in this unit we will cover the ferrous materials. So before going to detail in ferrous materials, why materials study is required? So here you can see one diagram which represent the material, then function, then shape and processes. So the material is related with the function, and the function is related with the shape, and material and shape are related with the process. So the process always interacts with shape, then the process is influenced by material, and the shape restrict the choice of the material and process depending on the function. So the function dedicates the choice of the material and shape. So all these are interconnected. Therefore, the material selection and the process cannot be separated from the shape and the function of the product. So there is a two-way interaction between all these parameters. So here we'll see the classification of engineering materials. So the engineering materials are basically classified into two categories. One is the metals and second one is the plastics. Metals are further classified as ferrous materials or ferrous metals and non-ferrous metals, while plastics are further classified in three categories, that is the thermoplastic, thermosets and elastomers. Ferrous materials, the materials which are the combination of ferrous, that is iron and carbon, called as ferrous materials or metals, in which ferrous is acts as a base metal and carbon acts as a allying element. So here the examples of ferrous materials are steel, stainless steel, die and tool steel, and cast iron. So these are the types of the ferrous materials. Next one is non-ferrous materials or metals. The metals where the other than ferrous, the another element is acts as a base metal, and allying elements are also there. So the non-ferrous metals, here some of the examples of non-ferrous metals like aluminum, copper, zinc, titanium, and tungsten. These all are called as a non-ferrous metals. Next is a thermoplastic. So the examples of thermoplastics are acrylic, nylon, ABS, polyethylene, polycarbonate, and PVC, that is a polyvinyl chloride. Then the examples of thermosets are called as the phenolic thermosets, polyamides, epoxies, polyesters. So these are called as a thermosets. And last type of material is elastomers, where rubber, polyurethane, and silicone. So these are the examples of elastomer. So this is the classification of engineering materials. Now we will go into the detail of every material. So ferrous metals or ferrous materials. So the ferrous metals are obtained from the iron ore. So you might recognize the letters Fe from the periodic table where they represented iron. So the ferrous facts, the iron replaced bronze as the principal metal by 1000 BC. Early pots and pans made up from iron are pioneered the user. Early steel were made by adding carbon to iron as it was melted over a charcoal fire. So the ferrous metal contains iron, will corrode unless protected, are attracted by a magnet, and are strong, rigid, and cheap. So these are the characteristics of the ferrous metals. So these contains the main element as iron, ferrous. Then if coating is not provided, then they will, or if protection is not there, then they will get corrode. So environmental oxidation reduction reaction will be there, and it will get corrosion will be there in the ferrous metal also. Then they ferrous metals are a good magnetism, showing good magnetism, magnetic property. So they are attracted by the magnet. Okay. Next, they are strong in nature, rigid and cheap. So this is the characteristic or properties of the ferrous metals. So these are the some of the examples of the ferrous metals. That is a carbon steel. This knife is made up of a carbon steel. Then this pan is made up of a cast iron, which is also uh, ferrous metal. And stainless steel is also applicable for the making of the household products. So ferrous is an adjective used to indicate the presence of iron. The word is derived from the Latin word that is a ferrum, that is iron. So the ferrous metals include steel and pig iron with a carbon content of a few percentage, and alloy of iron with the other metals such as stainless steel. So the manipulation of atom to atom relation between iron, carbon and various alloying elements establishes the specific properties of the ferrous materials or metals. Next is the grades of steel or types of the steel. So over 3,500 different types or grades of steels are exist. So commercial steel is generally classified into four groups depending on their metal alloy content and end use application. So first is a carbon steel, which includes low carbon steel, medium carbon steel, and high carbon steel. Second is the alloy steel, commonly alloy metals, manganese, silicon, nickel, and chromium. So when alloying elements are added into the steel, it will be the alloy steel. Next is the stainless steel, which contains 10% of chromium and classified as austenitic stainless steel, ferritic stainless steel, and martensitic stainless steel. And the fourth grade is a tool steel. So the alloyed with the high temperature and hard metals, so such as molybdenum and tungsten. So the for the cutting applicable, different tools are made up of this material, tool steel. So this is the four grades of steel. Next is the carbon and alloy steel. So here carbon steel. So the classified as a low carbon steel, medium carbon steel, and high carbon steel. So if the carbon percentage is less, that is less than what we can say 0.3% carbon, then such steel is called as a low carbon steel, or it is also called as a mild steel. So the application of this low carbon steel is manufacturing of bolts, nuts, and sheet plates. So you can observe the nut and bolts for the joining of the plates, and then different sheet plates or metal are made up of a low carbon steel material, which having a quite less strength. The second type of carbon steel is a medium carbon steel, which contains 0.3% to 0.6% carbon. So machineries are made up of this medium carbon steel material. Automotive and agriculture equipments are also manufactured by using the medium carbon steel. The third carbon steel is a high carbon steel, which contains the carbon percentage greater than 0.6%. So up to 2 to 2.1% carbon is present in the high carbon steel, which is used to manufacture the springs, cutlery, cables, etc. So these are the application of high carbon steel. They are quite good in strength and ductile in nature. Next one is alloy steel. So the steel containing the significant amount of alloy element is called as a alloy steel. So the structural grade alloy steels used for the construction industry due to high strength. So the other alloy steels are used for its strength, hardness, resistance to creep and fatigue, and toughness. So it may heat treated to obtain the desired properties into the steel. Next, high strength, low alloy steel. So the improved strength to weight ratio, then used in automobile bodies to reduce the weight and its agriculture equipment. Some examples of high strength low alloy steel are dual phase steel, micro alloy steel, or nano alloy steels are also there, which are comes under the high strength but low alloy percentage is there. Then second important ferrous metal is a cast iron. So it contains 1.7 to 4.5% carbon and 0.5 to 3% silicon. Then it has a low melting point and more fluid than the steel. So better castability is there for the cast iron. Then low cost material usually produced by sand casting. A wide range of properties depending on the composition and cooling rate are strength. So the cast iron having a good strength, then good hardness. Then some of the cast iron, just like a ductile cast iron, are in ductility, showing the good ductility. Then they are showing the thermal conductivity also. The damping capacity is also good. That is nothing but a shock absorption capacity or load carrying capacity is good for the cast iron. So that will be applicable for the lathe bed. So the cast iron, the ferrous alloys containing the sufficient carbon so that the eutectic reaction occurs during the solidification. So the carbon percentage is more in cast iron as compared with the steel. So the 2 to 6.67% carbon will be there in the cast iron. So here we can see the different types or the classification of cast iron, that it is a gray cast iron, uh, white cast iron, malleable cast iron, ductile or nodular cast iron, compacted graphite cast iron. So these are the types of cast iron which are formed by the pig iron with the combination of ferrous and carbon. So the production of cast iron, how the cast iron is produced. So initially we are having a pig iron or a scrap steel or limestone and carbon coke. Then a cupola furnace, that pig iron is going to heated, or it may be electric furnace or electric arc furnace or electric induction furnace. Usually sand cast, but can be gravity die cast in reusable graphite modes. They're not firm, finished by machining. So in this way, we can produce the cast iron. This is again a graphical representation or a chart-wise representation for cast iron. So the white cast iron, uh, gray cast iron, ductile cast iron, malleable cast iron, and alloy cast iron. So they are having a good castability, 2.4%. So stress concentration at flex tips is avoided. So you can see the schematic drawing of the five types of cast iron, that is gray cast iron, white cast iron, malleable cast iron, ductile cast iron, and compacted graphite iron. So here one first type is called as a gray cast iron, which shows the graphite plates. Second one is a white cast iron, you can say white cast iron. So there will be the combination of perlite and cementite. This white phase is the cementite, that is Fe3C, and this dark phase is called as a perlite. Then in third, that is a C diagram, it is a, you can say the malleable cast iron. So the graphite nodules are there in the form of dark phase, and bright phase is a, can consider it as a uh, cementite, or some amount of perlite is also there. And then nodular cast iron, you can see the graphite nodule which is surrounded by the white region, that is a perlite. Okay, so this dark region are in the spherical form, or it is also called as spheroids. That is a graphite made up of a graphite nodules are there. And last one is a compacted graphite iron, which contains the compacted or vermicular shape graphite. That this dark phase is a vermicular graphite. Graphite is present. So this type of cast iron is called as a compacted graphite cast iron. So in this way, we can learn the what are the types of steel and what are the types of cast iron, or the what is the difference between the steel and cast iron depending on the application. If there is a high duty rigid applications are there, then we can prefer the cast iron. And if there is a low load applications are there, then we can go for the steel material. Then some of the household components or equipments components can be manufactured by using the steel material. Then some of the machineries are also there, which are from our automotive parts are there, nut and bolts are there, springs also there, that are manufactured by using the steel material. And if the high good strength or damp products are required, then we will go with the cast iron, just like lathe bed is there. Then different walls are there for the safety walls are there. Pressure relief walls are there that are made up of pumps are there, pump facing, or different agriculture equipments are there, which are manufactured by using the cast iron material. So this is all about the steel and cast iron.